All right, welcome back. Last time I talked a little bit about geometric series and some of its characteristics and how it converges if the R common ratio is between -1 and 1. And I'm going to talk right now about two more specific type of series that you can determine very quickly if it converges or diverges. And so the first one actually has a name. It's called the harmonic series. And it's the series of the function 1 over n from 1 to however far you go. And so if I did the first few terms, it'd be 1 over 1 plus 1 over 2 plus 1 over 3 on forever. And instinctually, I see that the fractions are shrinking. Eventually it's going to be 1 over 100. And then 1 over 1,000 if you take it out 1,000 terms. But a fact you kind of need to memorize is the harmonic series always diverges. Accept it for now. If you do want to prove it, we actually proved it in class a couple months ago when we did like improper integrals. So if you do or remember how to do this integral, I could have used x's instead of n's. Remember we rewrote it as, b goes to infinity and went through this whole deal. You'll end up getting, or end up proving that, the limit doesn't exist and therefore it diverges. So you can go back and play with that if you want to. But for now, it's the harmonic series, this guy, and it always diverges. The P series kind of stems off from that. P series is any sum in this form, and so this could be 1 over n squared. This could be 1 over n to the 1/2. This could be 1 over n to the 10th. Notice for all these, the p value changed. So it's kind of the P series is the family of these. And it turns out, kind of like the geometric series, that there's a rule for this. And you can think of the harmonic series as 1 over n to the first power. And we know that when it's 1, it diverges. And so 1 is kind of the cutoff, actually. And so for a P series, the rule is if P is greater than 1, it converges. But if P is less than 1, it diverges. Some people prefer to think of it as P is less than or equal to 1. If you want to include that harmonic series in the things that diverge. All right, so those are two new rules for today. One additional rule that I wanted just to mention, because it's pretty easy, is the divergence test. Sometimes it's referred to as the nth term test. And it says that a series will diverge if the limit of the nth term does not equal 0. Note, this is the trickiest part, this cannot be used to determine convergence. So this is just a way to prove divergence quickly. For example, if I jump down here, you just learned it, but this is the harmonic series. So you know kind of the conclusion. But using this divergence test, it says that a series will diverge if the limit of the nth term does not equal 0. Well, the limit of 1 over n, as n approaches infinity, is 0. And so essentially the divergence test for this example is inconclusive. But I can go on to say, well, I know this is divergent because it's the harmonic series. If I look over at this example, the limit here, whether you use L'Hopital's, you're leading the leading coefficient, the limit as n approaches infinity of this thing is, you guessed it, 3. So what the divergence test is this is not 0. So instantly we can say that this diverges. Again, if it says that it is 0, you're going to have to use some other test. You cannot say, oh, because it doesn't diverge, it converges. It doesn't work like that. It's not an if and only if. Let me write that up here. Not and if, not and if and only if statement. A little cramped on here. All right, sign of n. It says a series will diverge if the limit of the nth term does not equal 0. I just put this on here to remind you guys that even though it wraps itself around 0, this limit is not 0. Whoop. The limit of sign as x approaches infinity does not exist. Just want to remind you of that. Okay, last page. I'd like to keep these short. So it says quickly determine if the following converge or diverge. I would like you to pause it and kind of stare at them for a second and then unpause it before I spoil the fun with all the answers. So take a moment and pause it. All right, hopefully you did. Here we go. Quick summary. The first one, -4, 3, and -1. So this is a geometric series. This R is too big. So converge or diverge, it's going to diverge. Switch my colors here just to mix it up. The second one, this is a P series, but the P is greater than 1. Some might say, well, what's up with the 6? And so remember, constants are nice. With summations, you could even pull the 6 out in front and think of this as a 6 and then like a 1 here. And so there's some algebra here, but just trying to introduce it. So this converges because 4 is greater than 1. All right, the third one. It kind of looks like a version of the harmonic series. You can think of it as 3 times 1 over n. And we know the harmonic series always diverges. The fourth one, we've got a quotient here. I'm looking at the leading coefficient. It looks like 4 divided by 2 would be 2. 2 is not 0, so by the divergence test, this diverges. Here down in the lower left, it looks like geometric, and it looks like 1/5 is your R, which means it's going to converge. Geometric is the only type where they might ask you what number does it converge to, and that's where you would use again that random formula, but you can try that on your own if you want. All right, the last two, almost done here. Here the limit is equal to 0. So I can't use the divergence test. But it's not geometric, it's not a P series, because I got some polynomials. And so at this point in time, this is inconclusive. I misspelled it, I think. Inconclusive. We don't have, we're not sure if it converges or diverges. And then this last one I just want to throw out here to get you thinking, because this is going to be the topic of my next lesson. The factorial is making an appearance. And so again, it's not geometric, it's not a P series, because I got this thing going on the top. I've also got an exponent down here. And so we don't have the tools yet, but we're going to learn a new test, and it's probably the biggest one and the most powerful. So if you want to think about it or get ahead or talk to someone about it, it's called the ratio test, but that'll be the topic of my next video. And so to be continued.